Hi everyone, so for today we're going to be looking at another probability type question. This one involves rolling a die. So let's see, it says an ordinary fairy die is a cube with the numbers 1 through 6 on the sides. Imagine that such a die is rolled twice in succession and that the face values of the two rolls are added together. This sum is recorded as the outcome of a single trial of a random experiment. Alright, so if you look at this chart here, what's nice is that they give you what all the possible events that could happen or possible outcomes that could happen. So if I look at, just to make sure we understand this chart, if I look at this first one here, that's just saying the first time I rolled the die, I got a 1. The second time I rolled the die, I got a 1. Okay? If I look at something like this, that's just saying first time I rolled it, I got the number 2. Second time I rolled it, I got the number 5. And so this chart's nice because, remember here, they want us to look at the sums. So whatever you rolled, let's look at the sums. Okay? So it says compute the probability of each of the following events. Round your answers to 2 decimal places. So for part A, we want the sum to be greater than 9. So the first thing I'm going to do before I even try to compute that probability is, given all these different possible outcomes, I'm just going to kind of add these numbers here. So if I look at this 1 and comma 1, that sum is a 2. 2 comma 1 is a 3. Then a 4. If you notice, there's a pattern here. 6, 7, right? And if I hit the, or go in the next column, 1 and 2 gives me 3, 4, 5, 6, 7, 8. And you can continue this pattern. You can see that it's 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, and so on. It's a little hard to see on this, but I think you get the gist of what I'm saying here. So now that I know what the sums are, notice the smallest sum you can have is a 2, and the largest sum is a 12. So it says the sum is greater than 9. So if we look at what I have here on the chart, we don't want the sum to be 9. We want it to be bigger than 9. So it looks like all of this gives me a sum bigger than 9, right? Those have sums of 10, 11, and 12. So how many different possibilities are there that have a sum greater than 9? Well, there's 1, 2, 3, 4, 5, 6. Out of the total sample space here, so if I look at the whole thing here, there are 36 possible combinations. So if I were to divide that, I get, it says round to 2 decimal places, so I get 0.17. Alright, event B says the sum is an odd number. So we're going to look at this chart again, and let's look at where the odd numbers are. Well, you can go through the chart one by one. There is a little easier way, but we'll talk about this. You know, I see that there's these diagonals. Do y'all see that? Then 9, then 11. So if you were to count all of those, you should get 18 of them. Okay, and again, the total is out of 36. And if you divide that, you get 0.5. Now you're wondering why it's exactly a half. Well, it's because when you roll and you're looking at the sums, the greatest sum you can have is a 12. Well, half of the numbers from, 2 to 12 are going to be odd, right? So the probability of the sum being an odd number is a half.